Welcome to Coding After Work stream. Today, we have invited Dan Moore to the stream to talk with us about OAuth for developers. But before we start, we would like to thank our sponsor, Progress Telerik.
They have amazing Blazor UI components with over 90 components now. They're adding every day, it feels like.
Yeah, basically.
Yeah. So if you're working with Blazor, you should definitely give them a try, or their components a try. And we'll add a link in the chat.
We also want to thank our sponsor, If Insurance. They want to decrease injuries in society, and they need your help. Crunching historical data with .NET technology to predict the future. That sounds kind of cool. And their tech community is over 900 people and is growing like never before.
We post all our streams and more on YouTube. So if you're not already following us on YouTube, please go and click subscribe and click the alert bell as well, so you get notifications whenever we post a new video. But now, let's bring in Dan Moore.
Yes.
Hi.
Hello.
Hello, folks.
So how are you?
Good. Thank you so much for having me. I'm excited to talk about Auth and OAuth today.
Awesome.
I'm excited to hear about it.
It's kind of a bold thing to say that you're going to be able to make it less scary. That's what we're talking about, right?
I hope so. Go ahead. Sorry.
Is that possible, even?
You know, it's funny. I think Auth is something like security that everyone knows they need, and everyone deals with it as quickly as they possibly can. But it is really kind of this rich thing, and it's one of those things that, like, the more you peel it back, the more subtlety there is there. So,
yeah, definitely. All right, let's. We're gonna bring your computer into the stream and take it away.
Perfect. Thank you. All right. So thanks for having me today at Coding After Work. I'm going to talk real quick about my employer, but I promise this is not a pitch fest. They're just paying for me to be here right now, so I got to mention them once. We are an Auth platform built by devs for devs, and basically what we let you do is we let you inject this component, and it's like more like a database server than it is like one of the components that the hosts were talking about. It's a standalone component that takes care of common authentication and authorization tasks like login, forgot password, registration, and you can basically use all this and make it look like your application without having to write it. So it really helps accelerate development and takes risk off your plate. So real quick about me, who cares? You can look me up on Twitter or LinkedIn if you want to know more about me. If you have questions, please go ahead and ask. I know there's a little bit of a lag, so I've asked the hosts to interrupt me if and when they see questions. So type them in, and I'll go back to the slide, and or the code, and we can talk about it more. So what am I talking about? I'm going to give kind of an overview of what Auth is, and then we'll talk about what OAuth is, which is slightly a different thing. OAuth is related to, but not a intersecting set with Auth, and then the problem that OAuth solves, and then we'll kind of dig into some deeper pieces, like how do you actually get a token with some diagrams, and then as a client and a consumer of that token, right? A client holds a token and a consumer consumes it. And sorry, I'm kind of jumping ahead here because I want to give you the overview, but a token is basically like a time-bound temporary credentials. Like you can think of it like a password that's like time-bound, that like gets you access to special things. So a client presents tokens to consumers and then gets access to data or other functionality. So we'll talk about how to care for tokens in that context. So let's take a step back, kind of go super high level and talk about what is Auth. And I've definitely had people ask me about this at conferences or in online communities. It really is a combination of the words authentication and authorization. And I learned the word portmanteau, I think that's how you pronounce it, when I was writing this presentation. Authentication is really who you are. So it can be offline, right? Like, so a passport book is a form of authentication. If I have this passport book and I present it to somebody, then they know who I am. It can also be online. And in online scenarios, it tends to be username and password, although there are lots of other options, right? Face ID, Touch ID, one-time passwords that get emailed to you. All of those help prove you are who you say you are. And, there are a number of ways to do this, but each of them is called a factor of authentication. So if you hear the word two-factor or the word multi-factor or MFA, that just means there's more than one kind of authentication that's happening to prove, again, you are who you say you are. Because that's really an issue, and it's an issue offline, but I'm not going to focus on that. I'm really going to talk about the online aspects, because that's one of the nice things about the internet is I can be talking to you all who are in Sweden. Some of you might be other places, but somehow the computer in Sweden or wherever it is needs to know that I am who I say I am without me being able to actually present anything in the way that I would present a physical piece of information like a passport book. But there are lots of common attributes with authentication. There's probably, there's a number of ways to do it, but there aren't thousands of ways to do it. There's probably 50, 25, something like that. They're all kind of common, and the implementations might be slightly different, or there might be gradations, right? It might be a different way to hash your password, but it's still a password that's being hashed. Authorization, on the other hand, is what you can do. So authentication is who you are. Authorization is what you can do. So I like to think of authorization, the common analogy I reach for is a car key. So if I have a car key and I hand it to a friend, or I hand it to a valet, or somebody takes it from me and they have access to the car, then they can start the car. And the car doesn't care who they are. The car doesn't know who they are. Having the key authorizes whoever holds the key to access the car and the functionality of the car, right? Drive off, do donuts or whatever. In the context of online systems, it tends to be role-based authentication or role-based access control. So users get handed at authentication or other times, they get handed certain roles, and then the application knows what they can do. You can also layer on attribute-based access control, which says not just who the user is, but what resource are they trying to access, what time is it, and any other kind of metadata that's around the access request. So authorization, in contrast to authentication, is really business specific. There are efforts out there to make it more generic, but an admin role in an accounting application is going to have different functionality and different access than an admin role in a to-do application, for instance. And then the other thing that kind of gets wrapped into auth is something called is user management. And that makes a lot of sense because you have users, because you need to be able to authenticate who they are, right? Find out who they are. And then you have access permissions, around roles or other authorization attributes that you need to basically know what they can do. Well, it's pretty easy to layer on like a basically create, update, delete list for users on top of that, so that then you can say, hey, I need to add a new user, or this user needs to move from role admin to role super admin or whatnot. So let's talk about kind of auth options when you're thinking about in the online world. The first and the simplest is don't use auth at all. If you can get by with it, you won't you'll remove a lot of problems, right? And so some of these options are online directories. If you have a website that is a public one that doesn't have any concept of a user, then put it all up on S3 or something similar and put a CDN in front of it, and you'll get great scalability, and you'll have zero auth security issues because there's no auth happening. This doesn't happen very often, but DuckDuckGo is an example of that. A public-facing website. Again, you can think of like your local rec center or government website might not have any concept of a user. The next thing you can do with auth, if you actually decide you have to have some way of knowing who a user is and what they can do, is you can roll your own. And so this usually starts out with the best of intentions, and usually you'll stand up a database and you'll create a table that is a user table. You'll have an email and a password, and then you'll start to add on additional functionality. So it seems pretty simple from the start, and it is to just kind of set up a first pass, right? But as soon as you dig into a little bit more, you want to make sure that you hash your passwords securely with the right algorithm and the right factor and the right number of times, and you store them securely, and it's a one-way hash. You don't want to ever encrypt your passwords. Don't encrypt your users' passwords, please. You also need to build functionality, right? Like a user, if you have a username and password, you're going to probably have users who forget their passwords. And if you don't want your customer service folks to hate you because people are calling them all the time to reset their password, you're going to want to provide an online way for them to do so, but in a secure manner, because you don't want anybody to be able to reset anybody else's password. You also might need to add in additional functionality like social login, right? Like, so that's login with Google, login with Facebook. I know some people still do login with Yahoo, I guess. You might also want to add some of those additional factors we talked about, right? So you might want to send someone an SMS after they've logged in, especially if they're going to do something like transfer money. Or you might want to use a Google Authenticator or some other authenticator app, or you might want to use Face ID or Touch ID. So you're going to need to bring that functionality in too. Then you want to think about different laws that apply to your users' data, whether that's data residency or the right to be forgotten. So you want to think about building in functionality that lets users either self-delete or at least give you a way that you can kind of roll up the user data and do a deletion if you need to. You also, especially if you're targeting a business audience, you might want to look at integrating with some other standards. SAML is a really popular one in the business world for offering single sign-on. So there might be a little bit more to rolling your own than you think about. So, it is not impossible to roll your own, and definitely people have done it. I just feel like if there are other options, you might want to explore them, because it's not impossible, but it is not easy. And the other thing that's really worth thinking about is the authentication experience and the authorization experience going to be a differentiator for your application? If it is, then it may make a lot of sense to roll your own. Just like if a database, or a data storage mechanism is really going to be a differentiator for your application, maybe you don't want to just use a relational database. Maybe you want to use something else. But for the vast majority of apps that I've seen, that I've built, that I've talked to people about, it is not a differentiator. It's necessary. It's absolutely necessary for most applications, but it's not sufficient. So the question is then, do you want to spend the time of your team and yourself building something that isn't going to differentiate your application or your service? And it is going to take extra effort. So, just be prepared for that. And it's not just initial build effort, it's ongoing effort, right? Because things change, new standards come out, CPUs get faster, which means you need to consider different password hashing techniques. There's a lot, just like any software, a piece of auth software is going to require care and feeding. And another way to put it, I kind of mentioned this before, but would you build your own database? And if the answer is no, then you should really reconsider if you're thinking about building or rolling your own auth. So what are some options? Dan, you've convinced me. I'm ready to not roll my own auth. What are some options? Well, the first is to use a library, and the second is to outsource to a dedicated auth server. And let's kind of dig into each of these, because they're both comparable. At this point, it's really about trade-offs. So you can use a library. I know there's a lot of .NET folks around here, so ASP.NET has some stuff built in. And actually, I have a sample app that I'm going to do a little bit of a walkthrough. I hope you'll be gentle. I'm definitely not a .NET coder, but I did manage to put together a sample app. And then there's some in other languages too. And a lot of these are really great because they snap in. Somebody else is responsible for all those pieces of functionality that I mentioned that you're going to want if you roll your own, right? Forgot password flow, password hashing, all those things. So it's simple to get started. And it really is simple operationally because it is part and parcel of your application. So it's just another piece of your application. And so when you want to deploy your app or when you want to upgrade your auth, you just redeploy your application and things are, hunky dory. It's kind of embedded in your application, which is why I call it the library approach. And it's really great for one application. Unfortunately, oftentimes this is not a true statement. There are more than one application, right? Even if you have kind of a super simple startup, like I did a startup a number of years ago, and we had the application itself. We actually ended up, after I left, building a second application that was custom. We had support ticket system. We had a forum, like a forum piece of software, and so it would have been really nice to be able to unify that so that we could have seen all of our users kind of in one place. And I've asked this question at conferences, and it is pretty rare that companies have just one application where they want to control access. So another option is this idea of an outsourced auth server. And by outsourced, I do not mean like you ship it over to Eastern Europe or India or whatnot. I mean that it stands alone. It's a standalone component, just like a database server. So it can have specialization and it can have additional features that don't make sense necessarily to roll into your auth, into your normal application. Um, an example of that might be a certain kind of deployment mechanism or, uh, certain application settings, right, that maybe are more secure than and might inhibit the behavior of your normal application. And so with that specialization, you basically get a team of extra devs that are pushing things forward. And some of this is true for the library as well. One thing that an auth server gives you that a library doesn't is a single view of the user, because you can basically set up a bunch of different applications, like I mentioned earlier, to all authenticate and authorize against a given auth server. And therefore, you can have one place for users to maintain passwords or other factors of authentication. You can see metrics about how many people are logging in and when. You can have a better onboarding and offboarding experience. That matters more for employees than it does really for customers, or for users. But again, with GDPR, you probably do need to have some kind of offboarding mechanism. And then it is better for the end user because they, instead of having 4 accounts to deal with your company, they have 1 account. You can choose an auth server that is standards based. And so we'll talk about one of those standards, which is OAuth or OIDC, in later slides. But the nice thing about being standards based is that you can avoid some chunk of lock-in. And the reason why I said sort of is because you don't avoid 100% lock-in, or you avoid lock-in 100%, because there are always, like any standard, there's always kind of subtle differences between, OAuth server 1 and OAuth server 2. But I will tell you that in my experience, you have a much better chance of being able to migrate from one auth server to another that are both implement the same standard than you do from your own custom auth server to another server that doesn't implement any standard. Right at that point, it becomes a totally bespoke integration project, and we all know how fun those are and how well contained those are. The other couple of great things about using a standard is that you can handle edge cases in a way that you might not even have expected to be able to, because basically how these standards get formed is a bunch of smart people get in a room, and these aren't smart people who are just thinking about the solution for a problem. They're actually people who've solved this problem before on their own, and they get in a room and they thrash out like, what are the commonalities of this problem, and how, well, I shouldn't say a room. Sometimes they meet physically. There's actually some great mailing lists that you can subscribe to that I'm happy to share, because all this happens in the open. And so, or maybe I should be careful here. Most of it happens in the open. And so basically you get all these experts who are probably using auth in a different way than you are, but they want to have a common solution to their problem. And so they specify it. And so then if you use an auth server that implements that specification, when that edge case comes up for you, you already have a solution. Somebody has already implemented that problem. An example of that's a real life example is what's called the device grant. And so if you've ever logged in on a TV to Netflix or any other the other kind of streaming services, you realize how miserable it is to enter your password. But the TV needs to know that you have access to Disney or Netflix or whatnot. So the device grant is a way that is codified. It's an RFC out of the IETF, which is a standards body. It's codified the way for the TV to send a request, basically let you log in on your phone and then pass the information from your phone to a server back to the TV that says this person actually really authenticated and they are who they say they are.
And
And
I love that.
yeah, it's
Because
like
typing your password on a TV, whoever came up with that?
it's
And for once, when you have a secure password,
You and it always happens when you have the room full of guests, so everyone is going to be able to see you. Where is that?
totally.
exactly.
Yep.
40 minutes later, and you don't have time to watch the series anymore.
The guests have all gone. They've gone home, right? They're not gonna hang out for that.
exactly.
The guests have gone home, and all of them now has your password.
Right. So, or at least the first 15 characters of it, right? Because they might have.
Yeah.
No. Yeah, I mean, it is kind of a true thing, and it's one of those things where you'll need it when you need it, but until you need it, you'll never even think about it. And so, there's some really smart people who've thought about that, and they haven't just thought about the edge cases. They've actually thought about like various attacks and how to defend these protocols that they've standardized against those kinds of attacks. And there are some people there. I'm on these mailing lists, and I'm not a contributor. I mostly read in awe. And there's people that like basically I could never, my company and probably your company could never afford to hire, because it's just a bunch of people who are just really into auth and security and spend time thinking about all these shades of gray and very subtle edge cases and security issues. So by using a standards based system, you get the benefit of all those people pushing things forward. You also get increased security if it's a standalone piece of your system, because you can, if you know your auth server is going to hold all your user passwords, that makes a pretty tempting target for attackers, because attackers love passwords, because then they get access to systems, and people tend to reuse passwords if they're not using a password manager. And then it's a high value target, so you can do things like limit access to it at the network layer. You can have increased monitoring around it, right? Anytime someone logs into this system, you might fire an alert. And in general, you can kind of reduce the risk, as opposed to if you have those 4 applications we talked about and they all have their own user table. Well, now you need to secure all of them to the same level, because again, password hashes are a really great target for malicious actors. And the final benefit of an outsourced auth server is really just focus, right? Your team gets to focus on building application features. And I'm not going to say it's not magic, fairy dust. You do have to do an integration with the auth provider and probably some customization, but you don't have to do the full amount of work that you do if you roll your own. And you also benefit from the focus of the outsourced auth server provider, because again, their job is pushing the product forward and making it more secure and making it more performant and adding features. And basically, if you leverage an outsourced auth server, and again, FusionAuth is one, but there are many others, you can benefit from those teams pushing their products forward. So you might say, well, Dan, you've made a pretty compelling case for an outsourced auth server, but I like the operational simplicity of a library. And why can't we have both? And that is a very good architectural path. you can grow from a library to an outsourced auth server. And the question is really when. And the things that I've seen that cause people to want to do this are if you have multiple applications, or you can foresee having multiple applications, if you need the data isolation for regulatory reasons or whatever else, if you want to carve out this piece of functionality from your main application so that your main application can be deployed more often or have different availability requirements, then an outsourced auth server starts to make a lot of sense. You want to prepare by using standards where you can, and actually, even in those libraries that are embedded in your application, you could actually kind of um, have them be an OAuth or an OIDC server, so that if you do end up building other applications, they can still, you may have one main one, which is where your core user database is, and it's basically an auth server plus some additional functionality. And then you can have other applications authenticate against that main application until such time as you want to carve off the auth functionality from the main application and port the data over to an outsourced auth server. And like anything else in life, it's easier if you do it right first. And the question then becomes, like, is this an architectural investment that you want to make, or is it not? And you'd rather wait until you have to basically extract out the user data from wherever it's landed and basically consolidate in an outsourced auth server. Those are kind of, it's totally they're both valid choices. They're just different trade-offs. Lots of choices.
But I like choices.
That's great. So if you're convinced and you want to use an auth server, let's talk about protocols real quick. And basically, again, speaking to some of the subtleties of authentication and authorization, there's a couple of different protocols that have been standardized. You could roll your own protocol, which I hope I've convinced you that in the auth space, rolling your own is going to lead you to some pain. You could use a proprietary protocol. I'm not super familiar with those. The two that I am familiar with are called SAML and OAuth/OIDC. And SAML is, I believe, was standardized in the 2000s, and it is unfortunately, it's widespread and has a few security kind of how do I put this gently? There are some issues
Bumps?
with security. Yeah, bumps. It uses XML, and XML has some kind of built-in security warts that you can work around, but it can be problematic. But the biggest issue I see with SAML is that it's not moving forward. Whereas OAuth OIDC was codified, the second version was codified in 2012, and there's actually a version 2.1 that people are working on actively right now. And so that is really, if you have the choice, use OAuth OIDC. So let's talk about an example application and kind of dig into some data flows. So we're going to do a to-do app here. And so what we want to do, we're going to become the next unicorn. We're going to take this notebook, which has basically it's just a checklist of tasks, and we're going to put that online. And here is our perhaps overly architected first architecture diagram of our system. So we have clients over here on the left, and then we have our two different APIs that are going to handle users and to-dos respectively. And we have made the choice to use an outsource auth server. And then the two APIs where the magic happens, right? That's really what our users want, is the features of adding the tasks and the to-dos. So in the nomenclature of OAuth, we have our clients, which are, again, a browser, a native app, something else, something that a user sits behind typically. We have our OAuth server, which is what I'm going to call it, but in the spec, it's called an authorization server, or it's actually abbreviated AS sometimes. And then we have our to-do API. And that I'm going to call a consumer because it really consumes the token, but it's also called a resource server or an RS. And that's what is protecting that resource server, is what serves up the functionality that we actually care about. So the OAuth server protects the user data and authenticates the user, But the to-do API is kind of our custom logic. It's our special sauce. So what problem does OAuth solve? And the answer is it really solves secure delegated access. So what I really want is a way for a client to be able to access the RS, the resource server, the consumer, but for the consumer or the RS to never see my password and my authentication credentials. Those I want to be managed by the OAuth server or the authorization server. So what we're trying to do is figure out a way for the client to present something to the to-do API without giving the to-do API kind of everything. If it was to, or without the having to log into the to-do API, basically. So the way that happens is with a token. And so I've mentioned before, a token is time bound and it is limited. So you present credentials, again, factors of authentication to the OAuth server, and it gives you back a token. And then that token can be presented to any service. And then that service can examine that token and learn things about the user and learn what roles the user might have, what permissions the user might have without ever needing to authenticate the user. So let's talk quickly about grants. So grants are basically flows that have been categorized by the OAuth standard and other standards. So they're given names because they encapsulate a whole lot of functionality, but it's basically a flow of a user, a client, and an authorization server and a resource server kind of all mixed together, how the data flows, what the protocol specifies. That's all wrapped up into something called a grant. And there are a number of grants that are defined. Some are defined in RFCs by the IETF, some are defined by other standards bodies. But the shorthand is if you are doing a situation like what we're doing with our to-do API where there's a user involved, and so we want to know, can Dan authenticate and then can Dan access Dan's to-dos, then you want to use the authorization code grant. That's the simplest thing. That's the most secure. It's the best choice. If, on the other hand, you are doing a situation where you need permissions between two different services, you can imagine if we have a to-do app, we might want to set up a reminder service that reminds me daily of what tasks I need to do. Well, in that case, there's no user in this picture, right? It's just a cron job running or a scheduled job. Well, in that case, you're going to want the client credentials grant. And then there's a bunch of other grants, as I mentioned. I already mentioned the device grant, and there are other grants for specialized purposes, but in general, you'll be pretty well served for typical applications with the authorization code grant and the client credentials grant. So let's dig into the authorization code grant. Let me have a drink. Have we had any questions or comments or sarcastic anything?
We had some jokes about TB had to put in his password when he logged into Twitch. So that was fitting on a day as today.
Awesome. Great. Okay. Well, let me charge on then. So the authorization code grant is if you had to pick just one grant to learn about, this is the one that I would suggest. It's pretty common. It's very secure. So here is our to-do app again. And we've actually introduced a new component, which is what I'll call the app backend, and we'll see what role that plays. But that is going to be a server-side component that you may or may not have to write. But before we kind of dive into these pieces and the authorization code grant in general, it's worth it to kind of think about things in kind of two different dimensions. The first is what's server side and what's client side. So clients, especially in an online world, are really unreliable. Someone can rootkit their mobile device and they can install other apps that can root around in any native application's memory, If you're running in a browser, of course, you have the problem of JavaScript dependency injection. If a website's been hacked or something like that, in the browser, if people put things in local storage, that's available to everybody. So you really can only trust things to be kept secret if you are holding them server side. Of course, they can still be attacked at that point, right? But it's a lot higher of a bar for someone to get a secret out of a server side component than it is out of a client side component. The other thing to think about is who's seeing a password. And so in this world, we really want, obviously, the client unfortunately has to see the password because the client is actually where the user types in the password. But after that, we don't want any other component of our system to see that other than the OAuth and user management platform. That, again, can be kind of a secure bastion, and we can load it up with all kinds of controls. And that way, the password, which necessarily gets passed in plain text, even if it's over SSL, it's still traveling in plain text, it would minimize the risk surface of what it gets access to that password. So the to API should never see the password. It should never need to. So let's kind of we're going to do the step-by-step the authorization code grant here. So the first thing that happens is you request a login page. And we're going to do the case with username and passwords. Again, there's additional complexities around adding on additional factors or using some other different set of credentials rather than username and password. Username and password is still pretty common and covers the concepts well. So that's what I'm going to walk through. So we request a login page from the OAuth server, and then we get back HTML. We then post to the authorization, the OAuth server, and it is going to validate that the username and password exists in the users table or the users database, and then it basically sends an authorization code to the client. And that authorization code is one-time use. It's high entropy, and it looks a little bit something like this. So it looks like nonsense to any normal person. It is URL safe. That code gets passed by the client to this new component called the application backend. And that application backend has previously registered with the OAuth system. And it takes that code that is basically indicative of this user authentication session, right? This one-time thing that this is a user authentication event. It takes that code. It also takes a secret, which uniquely identifies it with the OAuth system, right? So the app backend, the secret is like basically a username and password for the app backend. So you can have multiple different application backends, and each of them will be uniquely identified with the OAuth system. You take those two things together, and you present that to the OAuth system. The OAuth system now says, okay, I know this code is valid because it was a one-time use code, and it's also time bound, right? So it's not good for hours. It might be good for minutes. And I recognize this application backend that is presenting its own credentials to me. And so this seems like a pretty good authentication situation. So I'm going to hand back a token, and it can return multiple different tokens. We'll talk a little bit more about those. Those tokens then can get sent to the client, and the client needs to store those tokens safely as it possibly can, because it is a client and it is client side, so it's not going to be impregnable. But those tokens get sent down to the client. Now the client finally gets to do what it wants to do, right? Which is really present the to-do, is get the to-dos. Because no one ever says, oh man, I downloaded this app and the login system is just amazing. I really want, I love the login system. You should really check out this login system. People want to get to the features, right? They want to get to the to-dos in this case. So the client presents the token to the to-dos, to the to-do API, which then can examine that token, and we'll talk more about what that means, and verify that token is valid, and then get the to-dos for that user and pass them back. Typically as JSON, but it could be any format. And then the client can present the to-dos. And we finally have gotten what we want, right? Which is really presenting the user with the functionality that they really wanted. So let's talk a little about who's responsible for each of these pieces of the system.
Before you jump in there, we do actually have a comment. Don't worry about storing tokens safely. My municipality stores them in the URL, the safest place in the whole browser.
Oh my. Yeah, that's heartbreaking, because stuff that happens in URLs gets, as I'm sure the commenter knows, like people can see it. It gets stored in caches. Other JavaScript on the page can see it. Any proxies that are involved in your systems or in other people's systems that an ISP might put up can see it. So, man.
It's out in the open.
Yeah, for sure.
But the good thing is that you can take that URL and send it to someone else, and they will automatically be logged in. That's convenient.
Sharing is caring.
As you. I just hope they can't buy anything or pay your bill or anything.
Oh, yeah.
Yeah.
Do anything of importance, really.
Right.
Or privacy.
Totally. Yeah. I mean, it is kind of like it'd be like pasting their password into the URL, right? Like, there are probably systems out there where people do that, and they're not systems that I would want to be associated with or be a user of. But it happens. Well, thank you for sharing that.
But hey, it's just a medical system.
Oh, jeez.
Like, who cares about medical journals and stuff, right?
Lars.
That's not anything we need private.
You're gonna give me a heart attack. I'm gonna need a medical system pretty soon. Oh my god.
Oh, I know a page. You don't even have to log in or anything. I can send you a link.
Oh man, yeah.
Already authenticated.
Perfect. Saves time.
Yeah, no. Don't do that.
Yeah. Thank you for sharing that, Lars. That's goes in the horror stories archive.
Yeah.
For sure. All right. Well, let's go ahead and talk about responsibilities for the architectural piece. But thank you for interrupting me. And anybody, if you have any questions, by the way, I mentioned this at the beginning, I'd like this to be a discussion. And so if you have questions or comments or war stories like what Lars shared, please drop them in the chat. Appreciate it. So again, we have our architecture diagram here, and the OAuth and user management platform, again, typically is going to be the auth server provider, right? So that would be, again, an open source provider, a commercial provider, whatever it is, it's a standalone component, and they're responsible for that functionality. You obviously are responsible for writing your native app or your browser app if it's a browser app, and then you're responsible for the to-do API and that functionality, and any other APIs that hang off of that add functionality to your application. And then there's the app backend, which can be the responsibility of the app developer, but often is a library. And so for .NET, Microsoft provides a library that basically takes care of that token exchange and passing the client ID, the client secret, and the authorization code, and getting that token. And then you configure it how you want to, how you're going to move the token around. But the actual kind of code is taken care of for you. So let's talk about tokens real quick. I've kind of brushed over them a little bit, and I introduced them in the second or third slide, and it's worth digging into them a little bit. So the tokens that are relevant for an OAuth or /OIDC system are these. And OAuth is a framework. I probably should have defined this earlier. OAuth is a way to find out authorizations. What are users authorized to do, And OIDC is built on top of OAuth and is used to determine who a user is. And the reason why I kind of use them a little bit sloppily is that it's pretty common for them to be delivered together. And so I don't know if I've seen a single OAuth system that didn't have OIDC as a layer on top of it. So you're probably going to use them together. So OAuth has access tokens and refresh tokens, and OIDC has ID tokens. So access tokens, per the specification, it's 6749 or 6750, actually are opaque. So that means you cannot really examine them. They look like that authorization code that I showed you. They don't contain any information. Again, that's per the specification. In practice, they're often JSON Web Tokens, and JSON Web Tokens do have some inner structure. But what access token, it's really important to know that access tokens are presented to the consumer. So in that diagram, which I thought I had in my next slide, but I don't because it's a live stream, so you're getting it real. They are presented to the to-do API, right, to that resource server. And then the resource server examines them and determines whether they are valid and whether it can give back the data that was requested. Refresh tokens are opaque as well, and they are used to get new access tokens. So a client can get an access token and a refresh token at authentication and can store both of them. And when that access token expires, you can actually present the refresh token to the OAuth server and basically silently relog the user in. And then ID tokens are part of OIDC. By the spec, they are JSON Web Tokens, and they're authentication and authorization, and they can be used by the client. So the client can examine them and see, oh, this is Dan Moore, and then it can do things like it can display my name or other things like that. So ID tokens really are meant for the client, not necessarily for anything else. And access tokens, in the typical way they're used, are bearer tokens. And what I mean by a bearer token, remember when I talked about authorization back at the beginning about 45 minutes ago? Bearer tokens are like car keys. So if you hand a bearer token, or if you hand a car key to a valet, they can drive your car. If a bearer token gets found because it's in the URL, for example, totally hypothetically speaking, and someone else gets it, they can present themselves to the resource server, to the protected data, to the protected functionality as you. So that means a malicious actor who finds a JSON Web Token or finds an access token, and presents it to the API can get access to data that they probably shouldn't have access to. If a bearer token doesn't work, and there's reasons why bearer tokens are implemented, especially if they're time bound, they can be safe. But if a bearer token won't work, you can look into a couple of different specifications. I'm not going to talk more about these, but these exist out there. Depop is actually not a full specification, but I know there's some implementations out there of it. And MTLS is an IETF standard. And what these do is actually tie the token to the client that requested the token, so that it's cryptographically they tie it. And so the client basically, the token isn't like a car key. It's more like a biometric car key that is tied to my thumbprint that won't turn on the engine without my thumb being on the key. All right, so let's talk about this client. So again, we're talking about this native app, or it could be a browser, and it's going to be getting these to-dos. What should it do with this token? If it's sending it over the network, it should use HTTPS or SSL. Again, don't put it in the URL. We want to hide it from caches. It's a pretty simple thing to do. You don't know where a URL is being logged. And so if you have a token that essentially gives someone access to a protected resource, you don't want to put it any place that someone else would find it. If you're storing it on the client, then you want to think about a couple different options, and what you choose really depends on your security profile and what clients you're targeting. So if you're sending it down to a native app, you really want to store it in encrypted storage or the keychain. And both of these have the beneficial attribute of not being easily accessible to other apps running on your phone. And I will say that a lot of auth libraries handle that for you and take care of that token storage. So something to be aware of, something to read your documentation about, but you might not have to actually do it.
That's nice.
For browser storage, you can use cookies. And again, the app backend can send down the cookie. And if you're going to do that, you want to make sure you do an HTTP only secure cookie, because otherwise that any JavaScript running in the browser can access the token, and they could send it off to some remote server, and that remote server could then try to access your to-dos, which are probably pretty precious. After the cookies have been sent down and stored, then any requests that the application makes to a API that's in the same domain, and that's, a limitation, right? It needs to be in the same domain. The cookies get passed on transparently. And that's a big win, because you don't have to worry about sending them securely. They're just going to happen anytime JavaScript makes a request to an API. Again, you do need it to be in the same domain, and it does need to, I think you need to pass like with credentials true. Depends on the JavaScript API that you're doing to make the call, but typically you got to say, hey, please send the cookies along. But once you do that, it happens automatically. You don't have to worry about it. You also can store it in memory. So you can pass that down and store it just in memory. It's good for a single page application. Obviously, if someone reloads the page, they have to now relog in. That's going to be problematic. This is something that I've looked at and I've read about, but I've never actually done. So take this with a grain of salt. But you can store a token in a web worker, which again, all you're really trying to do is try to keep it away from any other malicious JavaScript running in your browser. And so if there's like if only the thing that started up the web worker can get access to it, that's going to protect the token. You also can use the BFF pattern, and that is not two young people heading to New York City and having a great time. It actually stands for the backend for front end pattern. And what that means is you never actually send the tokens down to the client. The app backend actually becomes the OAuth client. So you have your native app over here, and it's tied to the app backend via a normal plain Jane HTTP session, and then the token is stored in the session on server side. And again, there's that server side dimension coming in. Now we have our tokens, which are, again, temporary credentials. They are now in our protected server side environment. The downside, of course, is that now you're proxying everything through your backend, your app backend, and you end up having to maybe have some trouble scaling it, or if you want to horizontally scale it, then you have to have your sessions be sticky, and so it's a trade-off, right? Like you're getting better security in a lot of ways. You're also getting the ability to run analytics against the access patterns that the app backend is seeing to see whether there's anyone nefarious who's hitting the an API a million times a second. You can centralize that kind of intelligence in the proxy, but you're running everything through a proxy. So it's a trade-off. So let's talk about refresh tokens a little more in depth. So again, access tokens should be short-lived. Refresh tokens are longer-lived. And refresh tokens are presented to the OAuth server, to the authorization server, to create new access tokens. And the reason why is you can imagine a world without refresh tokens. And by the way, this is an example of something where it's a use case that the standards writers have thought of, that if you roll your own authentication protocol, you're probably going to run into this. So you have this token, and let's talk about an access token, right? So it's something that you can present to the to-dos API, and you can say to-dos API, give me these to-dos. And so it's basically a little mini set of credentials, a little mini password. If it's time bound and you are worried about someone stealing it, then you want the time to be short, right? Minutes, seconds. But if it expires, when it expires, the to-do API shouldn't continue to treat it as a valid token. Otherwise, why expire it at all? So that means when it expires, you need to get a new access token. Well, how do we get an access token? The user authenticates in a world without refresh tokens. The other option is you say, actually, screw security. I'm not going to worry about security. I'm going to make my access token good for a year. That way the user will never have to re-authenticate, or they won't have to re-authenticate for a year. And who cares? Like a year, asking for an access user to authenticate every year, that's pretty reasonable. But then if someone steals that access token, they have a full year to like harvest data. And that's obviously pretty problematic and pretty scary to think about. So let's talk about how refresh tokens solve this problem. So we have our to-do API again, and we have gone through the authorization code grant. So I'm not going to step through that again. We have our tokens on the client, and it is making requests to the to-do API, getting to-dos back, making requests, getting to-dos back, maybe making updates, marking things as done. And then if that access token is good for 5 minutes, after 5 minutes, the next request comes and the to-do API says, no, this is not a valid token. I am not giving you any to-dos. I'm not going to do what you asked me to do. Well, the client can catch that error, right? And it might be a 403 forbidden. It really is kind of system dependent exactly how that is communicated, that access token expiring is communicated, but it will be communicated. And the client can then say, well, gosh, I just made a request to the to-dos API and it got rejected. Well, I have this refresh token, so I'm going to present that to the OAuth system and hope that it's still valid. And if the OAuth system examines it and it knows that the user hasn't logged out, that the user's account is up to date, the OAuth system can know a lot more about the user. If everything checks out, then the OAuth system can pass back a new JSON Web Token, which I've indicated by JWT2 over here. And then that JWT2, which is good for another 5 minutes, can be presented to the to-do API. And the to-do API does its same validation, and it says, oh, yes, okay, you have a new token that is still valid, and it's good for another 5 minutes, so I'm going to give you the to-dos. And so what we've done here is essentially we've re-logged in the user, or we've re-authenticated them, or we've refreshed their activity session without them ever having to present their credentials to the OAuth system because of the refresh token. So as far as kind of refresh tokens, the client really needs to know how to handle them and needs to know when to use the refresh token and how to store it. And it needs to make sure it catches the access denied and then presents it to the proper place and stores the new access token safely. But the consumer doesn't care, right? The to-do API doesn't care. It just sees a token that's invalid, and then maybe a few seconds later, it sees a token that's valid, and then it's fine. It's all good. So let's talk about the to-do API and the consumer. So we're going to focus on this piece. What does it need to do around tokens? So a consumer basically, as I've mentioned, accepts the access token and returns valuable data. It needs to, in order to make sure that it hands back the correct valuable data and doesn't hand it back when it's not allowed, it needs to validate that token. And as I mentioned kind of initially, is also called a resource server or an RS in an OAuth system. So when you get this token, you need to as the writer of the to-do API, because remember, writing the to-do API is on you as the developer. You need to do two things. You need to you need to actually examine the access token, or you need to verify the access token is real, and then you need to obviously get the data and send that back. But I'm not going to talk about that second step because that's beyond the scope of this talk. But there are two options for you to validate that access token. First is you can examine it, and the second is you can introspect it. So let's talk about each of those. So examining the token only works if your access token is a JSON Web Token or some other thing that is a signed token. JSON Web Token is the most common protocol, so that's one I'm going to focus on. But I know there's some other ones out there, like Macaroons, I think is one that I've heard of. But we're going to focus on JOTs. So when you're examining an access token, you're going to validate the signature, and then you're going to validate the claims. So let's talk about what a JSON Web Token is. So this is a signed JSON Web Token. There are 3 parts to every JSON Web Token that's signed. And the first is the header, which is in green. The second is the payload in blue. And then the third is the signature, which is in tan down there. And the header and the payload both are just URL base64 encoded strings. And the reason why they both start with EY is because that's the start for a curly brace. So it's just JSON that's been URL encoded. The header is just metadata. So this is information about the JSON Web Token, what algorithm was used to sign it, other information. The body is where things get really interesting. It's also called the payload. And the keys of this JSON object are called claims. And they're basically claims about the holder of the token. And the important thing to note here, we're going to dig a little bit deeper in a little bit, but the important thing to note here is that the claims don't have to be just JavaScript primitives, right? Strings or ints or Booleans. They can be complicated data structures. The roles is an array, but you could have an array of objects or an object of arrays, whatever you want to have in this structure, which is why JOTs are so great, because they're very flexible. Also, JSON Web Tokens it's pronounced JOT. I don't know why. The signature is really, really important, because what that means is that you can basically, that Zoo API can validate that this JOT was created by the OAuth server without ever talking to the OAuth server, which obviously means that they can be separated by a network boundary, or they don't have to be, the OAuth server doesn't have to scale up to handle a bunch of requests from the Zoo API. So it's kind of standalone. And then how the signature works at a high level is you take the payload, you take the header, you append them together, you run a cryptographic algorithm over them with a secret or a key, and then that's what happens on the OAuth server side. And then when you get the JOT at the Zoo API via the client, you can do the same thing. And so you basically can kind of reverse engineer that same cryptographic function. And if the signature matches, the signature is then URL base64 encoded and appended to the JOT. So if the signature that the To-Do API gets matches the signature that it calculates, it knows that the contents of the payload and the header were not changed in flight, which means that it can trust it without ever talking to the OAuth server. So you obviously need to validate the signature. That's a pretty important thing to do. And if you're using an asymmetric key, which you're typically going to want to do, so you can sign a JSON Web Token with a symmetric key, which basically means that the OAuth system and the To-Do API have the same access to the same key. There are downsides to doing that. You're much more likely to use a private key up here and a public key down here. So the To-Do API needs to get access to that public key somehow. And one way you can do it is you can deploy it as part of the To-Do API deployment process. Another way you can do it is have the To-Do API reach out and grab the public keys that correspond to the private keys that were used to sign the JSON Web Token from a well-known endpoint. And this is another IETF standard. This is what that endpoint looks like. That's a lot of stuff. This is a smaller version of it. And the important things are that you have an algorithm, you have a key identifier, and then you have an array of public keys. And then the JOT that gets handed to the to-do API also includes an algorithm and a key identifier, and those can be used to match the public key that should be used to verify the signature of the JSON Web Token. If the signature is invalid, then you want to stop. And that means that someone's monkeying around and presenting you with JSON Web Tokens or access tokens that are not correct for whatever reason. You don't want to do anything more with that as the to-do API. Because again, remember, you're protecting those valuable tasks. The next thing you need to do if the signature is valid. Oh, and by the way, this is something that you're probably going to want to find a library to do to validate the signature. And there are libraries in pretty much every language I've ever seen. .NET definitely has them. JavaScript has them. Java has them. I've not run into a major language that didn't have a library to validate JSON Web Tokens, the signatures of them. So the next thing you need to do is validate the claims. And so the claims are, again, the keys of this JSON object. And some of these claims are standardized, are included in the JOT specification. Others are not. But the ones that you really want to make sure that you validate, and again, this is business logic now. You need to write some code yourself as a developer to validate these claims. Libraries typically won't handle all this for you. The first claim you want to validate is the ISS claim, which is the issuer. And so this represents the OAuth server. This is who created this JSON Web Token. So obviously you want to know who created a JSON Web Token before you treat it as a valid one. I've seen these be domain names. I've seen them be URLs. I've seen them be UUIDs. It doesn't really matter what it is, as long as the to-do API and the OAuth server agree on what a valid value is. Second is the expiration time. And this is the time beyond which this token is no longer valid. So this is defined in the spec as seconds since January 1st, 1970. And you just need to make sure that that number is in the future for you. If it's in the past, then that token is expired. Again, do not pass go. Do not let them have any to-dos. The audience claim, or the AUD claim, is a little bit different. It is, who is this JSON Web Token for? And so in the case of our application, it is for the to-do API. And this can be an array of values. And again, in this case, it's a UUID, but it doesn't need to be a UUID. All that needs to happen is that the to-do API needs to know this is some signifier that this JOT is for me. Because, and the reason why you want to check that out is because it's possible that someone could create a JOT from the same OAuth server, and it could be for like an accounting. Oh wait, I don't have. Nope, I don't have that. I thought I had a diagram here. So imagine that you have an accounting API, right? And that is what people use to provide the to pay their subscriptions for your to-do app. Well, that may have an admin role that is associated with it, but that admin role is probably different and is assigned to different people, different users, than the admin role for the to-do API. And so if you were to somehow be an attacker and somehow get access to a JOT that was for the to-do API that gave you an admin role, and you were to present that to the accounting API, then if that accounting API didn't look at the audience claim, it might say, oh, yes, this person's an admin. Oh, the issuer checks out. Oh, it's not expired. Okay, I'm going to go ahead and let this person have admin access to the billing stuff. That obviously is at worst or at best a bug, and at worst like a severe escalation of privilege. So always check the audience as well. And then you can check other things too, right? Like you can check scopes, you can check other business attributes. You could conceivably put things like what tier they're on. And if they're on the free tier and they have more than 10 to-dos, you could deny access or something like that. So hopefully I've illustrated that validating claims truly is business logic. Like you really have to, you can't expect a library to take care of anything for you, except for perhaps some of the basic stuff like checking the issuer or checking that the issuer matches some value you present or checking that the expiration time is in the future. So here's a little bit of code, and I have a sample application. This is all under the Apache license. And I honestly found a sample application and just kind of hacked it out. As I've said, I'm definitely not a .NET programmer, but I'm using the app settings. I think I want sample. Yes, I'm using the identity model ASP.NET Core. Package, and then I'm using the OpenID Connect version 5 package as well. And the important things here are, and the reason why I kind of want to do this is that lines 41 on, like these are some of the business logic that I've added, right? So I am going to add a couple of pieces of authorization that if my JSON Web Token comes back and it doesn't have the odd claim that matches something from my configuration, and it doesn't have an issuer claim that matches something from my configuration, then I'm going to fail authorization. And so the user won't be able to see the private page. Because basically what this is right here. I just have I stopped it. That'd be the reason. I'm sure that never
You're not
happened.
authorized.
Right.
Exactly, you're not authorized.
I'm authorized to run it.
But you need to have some issue with live demos. Otherwise, it's not a live demo.
Exactly. So I have, a privacy policy, a homepage that are okay, and then I have a page that I am actually is protected. And so if I log in, so this is actually going through the authorization code grant right now, and then I have I'm not
I'm full
showing
of
any
secure
yeah,
data.
exactly. I didn't know what to put there. So it does just show all the claims of the JSON Web Token. So that is what I am doing when if I were to let's go here. If I were to ask for a different claim, right? If I were to say, hey, it needs to have user type of premium, not user type of basic to get to that secure page. And I was to rebuild this. I might need to log out. So I'm logging out. So I go to secure. Again, I'm prompted. But it blows up. And that's just because I haven't set up an error page. But you can see this here. It says access denied. And the reason why access is denied is because I've set up an authorization option to require that claim. So
I think this is a really great demo because it's showing that a lot of these things are built into frameworks, so you don't have to roll a lot yourself when you're using these kinds of libraries.
Yep, absolutely. And you have to, and maybe this is more intuitive to you, to your listeners or your viewers who are more .NET savvy. Like I found the documentation a little bit frustrating to, excuse me. I found the documentation a little bit frustrating to like move around, but excuse me for a second. Hey. Sorry about that.
It's for sure a live stream.
Yeah, exactly. Wouldn't be a live stream without a video bombing. Yeah, so I found the documentation a little bit confusing, which is why I created this example app just to show some of our users how to do it with ASP.NET. But your point is exactly right. Like for that piece of exchanging the token, you really shouldn't be kind of rolling your own unless you want to like walk through it and get the steps through it to understand it. But like if you're just trying to integrate with an OAuth server, look to your framework, look for OIDC or OAuth. Client is the term, which client's kind of overloaded, but and it'll take care of a lot of these things. And then you can just configure things and trust that it's going to get executed correctly.
Yeah.
And I like the whole, you were mentioning some of that earlier. Do what you're good at. If you're good at coding, do the coding. If you're good at authentication and authorization, do that. And let me use your stuff so I don't have to care. Because I will not be as good as the people who actually wrote these frameworks and tools. There's no way.
Yeah.
That's a good way.
Because you need to think about so many different layers. And I found it very interesting to see how it all worked behind the scenes. Because for me, it's been, well, you add some magic and all of a sudden someone can log in.
Right.
But I found it very, very interesting to see how it actually works. Because I didn't have to care before.
Yeah.
And nice thing is you don't have to now either, right? Like now you have a good understanding and you can appreciate it, and then you can just, again, find the framework, follow the instructions, and do it well. And then rest assured that your users' data is secure, right? That their authentication process is going to be secure and safe. So, yeah.
Yeah, and especially when we have so many different regulations and rules, and you mentioned GDPR as one of the examples. I don't want to touch that. If I don't have to, that's like a whole other problem. So if someone already did the work for me, that would be awesome.
Yeah, definitely.
I sound very lazy.
I think
sound
the
like
word
a
you're looking for is
developer.
it's efficient. It's efficient.
Yes, that's the one. That's the one. Thank you.
Cool. Well, we're coming up on time. I can skip to the end. I think I do talk a little bit more about another way to check on tokens, but I don't want to be respectful of your time. So should I skip to the end or do you want me to keep going?
Keep going, I would say.
Yeah, sure.
Great.
Yeah, we have a comment. Efficient. Thank you, TB. And also know where your specialty is.
Yeah.
Exactly. Focus on your core competencies. Exactly. And we also gotta keep going. And to keep going.
Oh wow, great.
So
okay.
I think we're unanimous.
The people
If you have the time, we appreciate it.
Yeah, I definitely have another 15 or 20 minutes for sure, and I think that should be enough time to finish things up. So yeah.
Awesome.
Great. Okay. Well, so we talked about like looking at the JSON Web Token and actually like looking at like the claims and verifying that they are what we expect. And the nice thing about doing that is that we never have to communicate with the OAuth server, except for maybe get the public key to verify the signature, but we don't need to do that all the time. The other option is that you can actually do what's called introspection, and this is another standard that your OAuth server may or may not actually implement, but many do. And what happens here is when the To API gets this token, which again, per the specification is going to be opaque. It doesn't mean anything to anybody except for the OAuth system. You can actually, the To API can reach out and call an endpoint with the access token and say, hey, give me back the claims of this token. And so when that happens, you'll get back something like this, which you'll look and notice is very similar to a JSON Web Token, but it is the results of an introspection, which means that you don't need to check the signature because you're just saying, hey, OAuth server, you can verify that this was created by you. And if you hand back something and it's not created by, if the OAuth server gets a token that is not created by it, then it'll hand back, I think by specification, it hands back a much smaller set of data. And all that happens, I think, is it hands back active is false. So this is a way for the To API to offload some of that processing to the OAuth server. And of course, that's like just squishing things around, right? Like either the complexity is in the To API or it's in the OAuth server, and you have to scale up the OAuth server. And again, that's an architectural choice you can make, whether you want to push that ownership of the validation of the token to the To API or to the OAuth server. Either way, the To API should still verify some of these other claims, even if it doesn't validate the signature. So again, it's an RFC, review all server docs to see if it's supported. The biggest difference is that you must check the active claim if you're doing introspection, because that active claim will tell you whether or not the token is valid. So let's talk about some common JSON Web Token issues. And I put this section here because whenever I talk about JSON Web Tokens on online communities like Reddit or whatnot, people come out of the work and say JOTs are horrible. They aren't horrible. They're just another tool. You should definitely use a library. You should definitely be aware that even though they look like they're encrypted, they are not. It's just base64 encoding. So don't put any secrets in there. Don't put government IDs. Don't put passwords. Be careful about PII. You also want to be aware that the specification allows you to specify the JOT is signed with a none algorithm, and that means that basically there's no signature. And so that means that anybody who can create a JSON Web Token, which, as you've seen, is basically just creating a JSON object and URL encoding it and appending it to another JSON object and URL base64 encoding it. They can create a JOT that will give them kind of whatever claims they want. So again, you have to check the signature, and you should never use a JOT that has a signature of none, because it's basically unsanitized credentials. And you definitely don't want that, right? I mean, it's bad enough to take unsanitized user input. You definitely don't want unsanitized credentials. So the simple fix is don't ever allow none. And FusionAuth doesn't actually allow you to ever create a JOT with none. So alternatives to OAuth. So we've kind of walked through OAuth, right? We talked about auth. We've talked about authentication and authorization. We've talked about OAuth, how it's one of the protocols you can choose. We've talked about the different kinds of grants you might choose. We've talked about the authorization code grant in a lot of detail. We've talked about tokens. We've talked about refresh tokens. So thank you all for hanging with me. It's been a long presentation, but we're finishing up with some alternatives, and this is just a brief discussion of alternatives that aren't based on SAML, basically. If you're protecting APIs especially, you could think about API keys. And the issue with these is they're static and they're not time-bound. I guess you could build an API key system to make them time-bound. And I guess you could build one to like have them rotate, but you're going to have to do a lot of the building of that. I'm not aware of any standards around API keys. Maybe there are some. And then the other thing about API keys is there's no encoded info in them. So they're just kind of opaque strings. So you can't put other useful information there. You might have proprietary solutions. I know AWS built their own non-standardized API key situation that is time-bound. It's actually, I watched a presentation on the AWS API keys. It's really interesting. They have bound each API call to a time, a region, and I think even to a service. So it's pretty interesting the way that they dynamically create these API keys. You also could use sessions instead of the token dance. And again, that's a little bit like the BFF pattern. And that's it. So thank you. If you want to read more about OAuth, we do have a modern guide to OAuth, which is about 100 pages of talking through each of the different grants. It has code in it. I apologize, it is JavaScript. It's not .NET code. But we will ask for your email address if you want that free PDF, just to give you a heads up. We are hiring, unfortunately not outside of the US. But if you want to talk to me about memes or passwords or OAuth, there's my contact information. And I really appreciate your questions and your comments and the chance to talk to you all. So thank you.
Thank you so much.
Thank you. I thought I was going to think it was interesting, but not this interesting.
Awesome.
I wish I had this session like 3 weeks ago when I started implementing the Twitch API, because that would have been awesome.
That's great. That's great. Cool. Well, if they have any, if the viewers have any questions or anything,
We do have a thank you.
oh, thank you, Lars. I appreciate that, and thanks for sharing your
A
your
horror
answer.
story.
Yeah.
And he will also start looking in for how
Yep.
do you say that?
The EY. Yeah.
EY.
The UI.
Of course.
Yeah.
In all base 64 strings from this day on. Yeah.
I've done that. That's great.
Party.
Awesome.
That must be a party trick.
Must be.
Yeah, I think so.
And you got some cats in the presentation as well.
Cats!
Jessica has a thing for cats.
I do. Just a
Excellent.
tiny bit.
I didn't know that. Great. You can't really have a presentation without Grumpy Cat showing up. I mean,
I know. At least one cat. And it's a presentation.
awesome.
And we got another thank you for Tibby.
Thank you, Tibby.
This was fun. Are you less afraid of
I
Auth
am
now?
less afraid.
You are?
I can honestly say I'm a little bit less afraid.
Oh, that's cool.
Excellent.
I'm not afraid.
You're still scared.
Yeah.
Not
It's
scared
still a
for
little
your
bit scary,
life.
yeah.
Scared. There's a difference.
It is
There's
a
a difference. At least now you know where to go when you need when you don't need to do it yourself.
Yeah. Definitely.
Because we have learned, don't do that and don't put stuff in, don't put the tokens in your URL.
Definitely. 100%.
Things I learned today.
So thank you so much for
Yes,
joining us.
thank
It's been a very fast-paced session.
And awesome.
Yeah, definitely.
Again, thank you so much for having me. I really appreciate it.
Okay, until next time.
Until next time. And what are we doing next time?
I don't know. What are we doing next
What
time?
are we doing? So next time we are bringing in a friend from RavenDB.
Right.
Going to talk to us about how to set things up and all of that beautiful stuff.
Yeah.
So join us next week.
See you then.
Bye.